Hello and welcome to a transformative journey through module, implementing educational technology and digital tools in STEAM. This module is a key part of our project, Each Ludus, aimed at empowering educators like you to harness the power of technology in enhancing STEAM education. Today we embark on a path that will not only introduce you to innovative digital tools, but also inspire you to integrate them into your teaching, to enrich your students' learning experience. At the heart of STEAM education lies the integration of science, technology, engineering, arts and mathematics, aimed at preparing students for the complexities of the real world. This educational approach champions a multifaceted understanding, critical thinking, and the application of knowledge. As we venture further, we'll explore how digital tools are revolutionizing STEAM education. These technologies are not just supplementary, they are transformative elements that make learning more engaging, accessible, and effective. From virtual labs that simulate complex scientific experiments to digital platforms that allow for creative expression in the arts, these tools are enhancing the educational experience in unprecedented ways. Our discussion will also cover how these digital tools are transforming educational approaches. It's about more than just using new technologies. It's about rethinking how we teach. By integrating digital tools into STEAM education, we're able to deepen students' understanding and expand their creative capacities. This transformation is not just about absorbing information, but about engaging with it dynamically, making learning a more enriching and interactive experience. The pathway through today's module is marked by three pivotal objectives. First, let's understand the critical role of technology in revolutionizing STEAM education. Technology isn't just a tool, it's a bridge to new ways of thinking and learning. It enables interactive and experiential learning that can make complex scientific and mathematical concepts tangible and exciting. Through real-time simulations and interactive modules, students can see the immediate impact of their actions, enhancing both understanding and engagement. Technology's power to enhance learning lies in its ability to make education more interactive. For instance, coding platforms like Scratch not only teach programming, but also logical thinking, by allowing students to build their own games and stories. Augmented reality, AR apps bring abstract science concepts to life right before students' eyes, and math visualization software transforms complex equations into visual experiences that are easier to comprehend. As we explore effective digital tools for the classroom, our focus extends to how these tools can be seamlessly integrated into your teaching. Scratch, for its part, facilitates creative problem solving. AR apps enhance engagement in science classes by overlaying digital information onto the real world, and math visualization software provides dynamic ways to explore and understand mathematical theories. Developing strategies for integrating these technologies into teaching is crucial. It involves understanding not just what these tools can do, but how they can be woven into your existing lesson plans to enhance learning outcomes. This segment will delve into frameworks that help you embed new technology effectively, ensuring it complements and enhances your curriculum rather than overshadowing it. We'll explore practical frameworks for technology integration. These frameworks guide you in selecting the right tools for your educational goals and aligning them with your lesson plans. The key is to ensure that technology supports the learning objectives, enabling a fluid and cohesive educational experience. Technology in STEAM education acts as a bridge, connecting the dots between abstract theories and tangible applications, thereby rendering the learning process more comprehensive and engaging. It's a bridge that allows students to traverse from the theoretical to the practical, making the learning journey both meaningful and memorable. For instance, consider the impact of a simulation that allows students to virtually conduct a physics experiment, observing the principles of motion in real time. Such experiences not only foster a deeper understanding, but also ignite a passion for learning. This part of our session will provide an in-depth look at practical examples where technology integration has transformed traditional STEAM lessons, offering a blueprint for innovative teaching. First, let's talk about Scratch. Scratch is more than just a coding platform. It's a gateway to the world of computational thinking. By allowing students to create their own interactive stories, games, and animations, Scratch helps develop essential skills such as logical thinking and problem solving. Its visual programming environment makes it accessible for students of all ages, encouraging creativity and exploration in a fun, engaging way. Next, we move to Tinkercad. This user-friendly, web-based application for 3D modeling and designing is revolutionizing how we teach 3D design and printing. Tinkercad allows students to create models from simple geometric shapes, making the leap from abstract concepts to tangible objects. It's particularly effective in demonstrating the principles of engineering and design, providing a hands-on experience that enhances spatial understanding and creative problem-solving. Finally, let's explore Google Earth. This tool does more than just map the globe. It brings geography to life. With Google Earth, students can explore detailed satellite imagery and 3D terrain of any location on Earth. This geographic exploration tool is invaluable for teaching not only geography, but also environmental science, history, and more. By interacting with real-world data, students gain a deeper understanding of the planet and the various forces shaping it. These digital tools, Scratch, Tinkercad, and Google Earth, are just a few examples of how technology can be utilized to enhance STEAM education. Each tool offers unique opportunities to make learning more interactive and impactful, helping students connect with educational content in innovative ways. As educators, incorporating these tools into our classrooms can help us meet the diverse learning needs of our students and prepare them for the future. Let's focus on two interactive learning platforms, Kahoot and Quizlet, which are instrumental in turning traditional learning scenarios into highly engaging and effective educational experiences. Kahoot and Quizlet are more than just digital tools. They are gateways to interactive and personalized learning. These platforms transform the educational landscape by making learning more engaging and providing immediate, personalized feedback. This approach is crucial for enhancing student engagement and retention, as it allows educators to tailor the learning process to individual needs and preferences. Both platforms use game-based learning mechanisms that increase student participation and enthusiasm. They offer real-time feedback to students, helping them understand their progress and areas needing improvement right away. The interactive nature of these platforms helps in better retention of information through repeated exposure and reinforcement in a fun environment. Let's take a closer. Kahoot can be used effectively in a classroom setting. Imagine a mathematics teacher preparing students for an upcoming algebra test. The teacher decides to create a Kahoot quiz to review essential algebraic formulas and problem-solving techniques. By doing so, the teacher can engage students in a competitive and fun review session. Use the quiz to assess students' understanding of algebra in real time. Provide instant feedback to the entire class, addressing common mistakes or misconceptions immediately. This practical implementation shows how interactive tools like Kahoot can make traditional review sessions more dynamic and informative. The use of such platforms not only supports the academic development of students, but also keeps them motivated and engaged, making learning a more enjoyable process. As we have seen, platforms like Kahoot and Quizlet are essential components in the modern educational toolkit. They provide dynamic ways to enhance learning and engagement through interactivity and feedback. We encourage all educators to consider integrating these platforms into their teaching strategies to witness a significant transformation in student engagement and educational outcomes. VR and AR are more than just cutting-edge technologies. They are powerful educational tools that bring abstract concepts to life through immersive learning experiences. These technologies allow students to interact with 3D models, participate in virtual labs, and explore complex environments that would be otherwise inaccessible. VR immerses students in a fully interactive 3D environment, making it ideal for exploring scientific phenomena or visualizing mathematical concepts. AR overlays digital information onto the real world, engaging students in a mixed reality that makes learning more interactive and enjoyable. Both technologies foster a deeper understanding by allowing students to experience and interact with the subject matter in dynamic and innovative ways. Imagine a biology class where students can use VR to travel inside the human body, exploring organs and systems up close, or an architecture lesson where students use AR to project their 3D models onto the physical space of the classroom. These applications show the vast potential of VR and AR to enhance educational outcomes by making learning an active and engaging process. To effectively integrate VR and AR in your classrooms, consider the following. Start with simple applications, such as using AR apps to visualize geometric shapes or historical artifacts. Gradually introduce more complex VR simulations, like virtual chemistry labs, where students can conduct experiments safely and repeatedly. Ensure that the content delivered through VR and AR aligns with your curriculum goals and enhances the learning objectives. Virtual and augmented reality are transforming STEAM education by providing immersive, engaging, and profound learning experiences. These technologies are not just about seeing, but about experiencing and understanding at a deeper level. As educators, it's an exciting time to harness the potential of VR and AR to make our teachings more impactful and memorable. Think of a lesson in which students will apply principles of physics and engineering to design and simulate the construction of a bridge using Tinkercad. This lesson aims to enhance students' understanding of structural engineering concepts and improve their problem-solving skills through a hands-on digital project. We start by diving into Tinkercad to create our bridge designs. This hands-on project lets students apply physics principles directly, turning abstract concepts into tangible models. As you design, think about the forces each part of your bridge will need to withstand. Next, we'll simulate real-world stresses on our bridges right within Tinkercad. This critical step helps us see which designs stand up to the pressures of physical forces and which ones need rethinking. Pay close attention to how your bridge reacts during the simulation. It's a great way to see physics in action. After testing, we'll discuss what we've learned. Reflect on your design process and the outcomes. Ask yourself what design changes might improve your bridge's strength or stability. To wrap up, remember that today's activity isn't just about building bridges. It's about bridging the gap between theory and practice. Keep exploring Tinkercad and consider how you can apply these lessons to other real-world challenges. For homework, submit a brief report on your design process and the insights gained from the simulations. Include any changes you'd make based on today's results. Integrating technology into STEAM education faces significant challenges, including limited resources that restrict access to advanced tools and a wide disparity in technology proficiency among educators and students. To combat these issues, educators can take advantage of a variety of free online resources. For example, platforms like PHET provide free interactive simulations in physics and chemistry, which can be instrumental in teaching complex scientific concepts without the need for expensive lab equipment. Professional development programs, such as those offered by the International Society for Technology in Education, ISTE, help educators improve their technological fluency and learn to incorporate digital tools into their curricula effectively. Additionally, peer collaboration through online forums and educational communities, like Teachers Pay Teachers, allows educators to share lesson plans and resources, thus democratizing access to quality teaching materials. In terms of practical tools, Kahoot makes it possible to create engaging quizzes that facilitate learning and assessment in a fun environment, addressing varying levels of student engagement. Tinkercad is an excellent introduction to 3D modeling and can be used to design prototypes in engineering projects, making abstract engineering principles more tangible and comprehensible. Scratch, a block-based programming language, enables students to create games and animations, which helps in understanding coding logic and fosters computational thinking. By integrating these digital tools, educators not only overcome barriers to effective STEAM education, but also enhance student learning outcomes through more engaging and interactive experiences. This section explores sophisticated technological applications that significantly enhance teaching and learning in STEAM subjects. Consider the integration of machine learning, which can transform students' understanding of complex systems, such as genetic patterns or ecological changes. By using simple Python scripts with libraries like scikit-learn, students can engage with data-driven predictions, making abstract concepts concrete and interactive. Furthermore, advanced robotics using platforms like Arduino or Raspberry Pi introduces students to real-world engineering challenges. These platforms facilitate the creation of programmable projects that embody engineering principles, such as automated devices or basic robots, thus demystifying technology and fostering problem-solving skills. Additionally, incorporating data analysis tools such as MATLAB or R into mathematics instruction can elevate students' ability to handle high-level computations and visualizations. Through practical application, students can model statistical data or explore complex mathematical models, bridging the gap between theoretical mathematics and practical application. Assessment in technology-enhanced classrooms needs to align with innovative teaching methods. Digital portfolios, for instance, allow students to continuously showcase their projects and reflect on their learning process, providing a comprehensive view of their educational journey. Interactive quizzes and exams facilitated through platforms like Kahoot or Google Classroom, offer real-time feedback, enabling educators to quickly gauge student understanding and adjust instructional strategies accordingly. Moreover, project-based learning assessments can integrate digital presentations or models, allowing for dynamic demonstrations of student work. These formats not only assess comprehension and application of STEAM concepts, but also encourage students to develop presentation skills and digital literacy. Building a community of practice among STEAM educators is pivotal for continuous professional growth and resource exchange. Digital platforms like Microsoft Teams or Slack enable real-time sharing of resources, lesson plans, and teaching strategies among educators, fostering a collaborative environment. Professional development platforms such as Coursera or edX are vital for educators to stay current with new educational technologies and methodologies. Participation in these courses can enhance an educator's skills and introduce them to a global community of peers. Local meetups and workshops facilitated through platforms like Meetup or Eventbrite also play a crucial role in community building, offering opportunities for face-to-face interaction and collaboration. The realm of educational technology is evolving at an unprecedented rate, with artificial intelligence (AI) leading these transformative changes. AI technologies, such as adaptive learning systems and automated tutoring, are fundamentally altering the landscape of personalized education. A prime example of this innovation is ChatGPT, an AI-driven tool that has been effectively integrated into various educational settings. ChatGPT offers personalized assistance to students, adapting explanations and providing customized support to help clarify complex topics. This capability enhances traditional teaching methods by ensuring that no student falls behind due to misunderstandings or gaps in knowledge. On one hand, educators praise Chat for its ability to provide immediate, tailored assistance, making learning more accessible for all students. On the other hand, some critics argue that reliance on such AI tools could potentially diminish critical thinking skills, as students might become accustomed to receiving answers without sufficiently grappling with challenging material themselves. This debate highlights the need for a balanced approach in integrating AI technologies in education, ensuring they complement rather than replace traditional educational interactions. As we draw this session to a close, it's clear that the journey of integrating digital tools in STEAM education is one of continuous exploration and innovation. The potential of technology to transform the educational landscape is immense, opening up new avenues for teaching and learning. We've touched upon various tools and strategies today, but this is merely the beginning. We encourage you to take the insights and knowledge gained from this webinar and apply them to your teaching practices. Experiment with the tools we've discussed, share your experiences with peers, and continue to explore the ever-evolving world of educational technology. Together, let's forge a path towards a future where technology and education converge to unlock the full potential of our students. Thanks for joining and watching us.